So for example 5, notice they're already giving us the diagram, and they want us to use our calculator to find the area for region S and region R. Now they're not being explicit in terms of saying we have to do it with respect to X or respect to Y. So here's my two functions. So let's talk about region S first. So region S is this yellow region right in here. So clearly you can see that you have a function that's on the top and you have a function that's on the bottom. So we can do this with respect to X. So again, they're giving me my two functions. F of X is equal to tangent of X. So I'll call this my F of X. 2 minus X to the third is what I'm calling my G of X. So to find the area of region S, again, I can do top minus bottom. Notice the graph that I've highlighted in blue, that is the one that's on the top. So that is my G of X. So I'm going to write that as my top. F of X, the one I have sketched in orange, that is the one that is on the bottom. So I'm going to call F of X my bottom. Now the only thing left to do, remember, is I have to find my bounds, which means I have to find this point of intersection. So I'm going to go ahead and load F of X under my Y1, G of X under my Y2. Again, make sure you are in radian mode. So I'll type in tangent of X under Y1, and I'll type in 2 minus X to the third under Y2. So notice I am in quadrant 1, so again, I'm going to just adjust my window. I may need to change that a little bit. So right now I have my X-min from 0 to 5, my Y-min from -2, my Y-max to 2. Let me see what kind of picture that'll give me. So I know that I have a vertical asymptote right here at pi over 2 for tangent of X. So I'm just going to go ahead and change my X max to pi over 2. So now you can just see it a little bit better. So here's my region S. This is my region R. So now let me go ahead and find this point of intersection. So I end up with 0.902155 and 1.657. So here's my point of intersection. I'm just going to go ahead and write this as 0.902155 and 1.12657. So then my area for region S is going to be my antiderivative from 0. Again, I'm using my bounds in terms of X. 0.902155. Again, top is my G of X minus F of X dx. So now on my home screen, remember where I have G of X loaded, that's under my Y2. So on my home screen, I'll go to my alpha window, option 4. Again, my bound's going to go from 0 to 0.902155. And again, it's going to be Y2 minus Y1. And I end up with a region of about 1.1605. So that takes care of region S. Now for region R, which I'm going to color it in red. Notice we cannot really do top minus bottom. This is a case where I'm going to have to do the area with respect to y. I'm going to have to do a right minus left. The function on the right is my blue graph, which is the 2 minus x to the third. So, but what I have to do here, first of all, remember I have to solve the equations for x. So right now my one equation is y is equal to 2 minus x to the third. So since I'm going to do a right minus left, I have to make sure I solve each of these equations for x. So I'm going to add x to the third and subtract y on both sides. So I have x to the third is equal to 2 minus y. And then I'm going to do my cube root. Let me rewrite this, hold on. So x to the third is equal to 2 minus y. And now I'm going to do the cube root of both sides. So x is equal to the cube root of 2 minus y. So I can call this my g of y is equal to the cube root of 2 minus y. Now I have to do the same thing for my other function. I've got y is equal to tangent of x. Well, this is where I'm going to have my inverse tangent of y. So x is going to be equal to the inverse tangent of y. So f of y is equal to the inverse tangent of y. So now what you have to do on the calculator is you do have to reload your functions under y1 and y2. So I'm going to put my g of y under y1, my inverse tangent under y2. So under y1 I'm going to go to my math. Hit my cube root of 2 minus y. Now you can't change this x to a y, but in terms of the calculator, our calculations will still come out accordingly. We're not going to look at the graph because the graph is going to be translated a little bit, but again, calculus for calculation purposes, we'll be able to come up with the correct answer. So then there's my inverse tangent of x. So now going back to my home screen, to find the area for region R, I'm going to do a right minus left. So the function on the right, it was my 2 minus x to the third. So when I rewrote that in terms of x equals, remember that's loaded under my y1. So it's going to be the area under the curve from 0. Now remember, you're using now the y coordinate for the point of intersection, which is your 1.12657. And it's going to be my g of y minus f of y, dy. Remember, I've got my cube root of 2 minus y loaded under y1 on my calculator. Inverse tangent of y is loaded under y2. So I'll do my alpha window, do my integral, 0 to 1.12657. Again, it's going to be my y1 minus y2. And up with 0.722. Right? Just remember, when you have to do right minus left, you've got to make sure you solve each equations for x. Okay, so find a vertical line, x equals k, that divides the area enclosed by x equals square root of y, x equals 2, and y equals 0 into 2 equal parts. Well, first of all, if I solve this equation for y, this is equivalent to y is equal to x squared. So let's go ahead and take a look at our picture. So again, I want to find a vertical line, x equals k, that divides our area enclosed by y equals x squared. X equals 2. So there's my line, x equals 2. Y equals 0, remember, is just my x-axis. And y equals x squared, when x is 2, the y value is 4. So I know that these two graphs are intersecting at 2, 4. So what I'm trying to do is I want to find, there's my area, bounded by those 3 equations. And I want to find at some place the line y equals k that will divide this area into 2 equal parts. Well, first of all, I need to calculate the entire area. So I know my area is going to be equal to the bounds from 0 to 2 of x squared dx. So when I integrate, I'm going to end up with x to the third over 3. And again, when I plug in my upper and lower bound, I'm going to end up with 8/3. So that's the area under the curve from 0 to 2. So now what I want to do is I want to figure out a particular x value, which means I want to solve for a bound, where I'll calculate half of 8/3. So half of 8/3 is going to be equal to some region from 0 to k of x squared dx. So half of 8/3 gives me 4/3. And again, when I integrate, I end up with x to the third over 3, and I'm going to evaluate this from my upper bound of k to 0. So 4/3 is equal to k to the third over 3 minus 0. So when I cross multiply, that's going to give me 12 is equal to 3k to the third. 4 is equal to k to the third. K is equal to the cube root of 4. So this is the k value, the cube root of 4, which as a decimal is equivalent to 1.587. So K is equal to the cube root of 4. That's the X value that would divide this region into 2 equal parts. So here they're giving me a graph, for example 7, that shows acceleration versus time for the 2 cars that move along the track. What does the area between the 2 curves represent? Justify your answer. So first of all, I have my area between these 2 curves. So I know that from 0 to some time t, that I could take the antiderivative from a sub 2 of t minus a sub 1 of t dt. Well, I know the antiderivative of the acceleration is going to be my velocity, which will be equal to v2 of t minus v1 of t. So in essence, what this means is the difference of the 2 velocities at time t. So here's another example where they're giving us a graph of a medication absorbed into the bloodstream of an individual and the rate at which it's being metabolized. Both rates are in units displayed over an 8-hour period. What does the area between the curves over time 0 to 8 represent? So the area between the 2 curves is the amount of medication in the bloodstream from time t is equal to 0 to t is equal to 8. Since both these graphs both represent the absorption rate and elimination rate, then we're talking about the total medications in the bloodstream from time t is equal to 0 to time t is equal to 8.